All right, let's check out this question. So here we have, it says a conical paper cup is 10 inches tall with a radius of 20 inches. The bottom of the cup is punctured so that the water level goes down at a rate of 2 inches per second. At what rate is the volume of the water in the cup changing when the water level is 8 inches? So a conical paper cup. So what three-dimensional shape is that? If we look at our formula page here, which of these, we're talking about volume, so it's a three-dimensional shape. So which of these is a conical shape? Good. If you selected cone, that's exactly right. So when they say a conical paper cup or a conical object, that's it's a cone. And what is the formula for volume of a cone? Good. If you got 1/3 pi r squared h, that's great. You can use this one too. B, capital B is just the area of the base, which if it's a circle, it's pi r squared, right? So that's all that means. So going back here, we know we wanted to relate, we wanted to find eventually the rate at which the volume is changing. So we need a volume formula, and we're given radius. And we're also talking about tall, how tall it is, or the water level, and we'll talk about that in a second. But let me just write out the formula for volume of a cube is 1/3 pi r squared h. Okay. All right. So now let's look at the shape here. A cone is a little more complex than some of the other shapes that we've dealt with. So let me just draw a cone and let's kind of talk through it. And don't be intimidated by my art skills here. So I don't know if you can draw a cone that well, but if you can't, no shame, no blame, right? So I'm just kidding. Hopefully those of you that are accomplished artists out there aren't offended by my artwork here. So anyway, so we have this cone, and what we know about it is that it's 10 inches tall, right? And so so the 10 inches is the height. Okay, so that's the height of our cone. So when they say how tall it is, that's in reference to the height of our cone. And then it also tells us that the radius is 20 inches. Okay, so radius here is 20 inches. So that's this. And you can see that my cone isn't drawn to scale, right? So this cone would be wider than it is tall, and that's not the way mine looks. So, but that's okay. You don't necessarily have to draw it to scale. We're just trying to identify relationships here, right? So no matter what those values they give me, I usually just draw the same cone every time, right? And then I can just relate those values. All right, so we know that relationship, and you can see what's happening here is we have a right triangle, and so so that'll come into play here in a second. So we have a right triangle. We know that the cup itself is 10 inches tall and the radius is 20, but then the water level goes down, right, at a rate of 2 inches per second. And so water level is the same as height, right? The water level is the height of the cone. And so so we know that h prime, right, the rate of which the water level goes down is 2. So we have to make that -2. All right, and they don't tell us -2. We just have to infer that, right? And then it also tells us here that the water level is 8 inches, right? So that means the height at the point we want to find the rate of volume changing, the height is 8, right? So that means the water level here, right, at that point in time is 8. So the height is 8 at that point. Okay, so we have basically a new triangle. So so if we were to examine these triangles a little more closely, we'd see that these triangles are actually similar triangles. They have the same, they share the same angles, right? This angle is shared, and so by reflexive property, they're the same. These are both right angles, and so by angle similarity, these triangles are similar, which means that the sides are proportional, right? So what we have is we have a relationship between r and h, between radius and height. The reason this is important is because here we have our volume formula has two variables, r squared and h, and we can work with that. Like, we can do product rule and separate those and all that, but they don't tell us R prime, right? So if I were to take the derivative of this, I'd have to use product rule, which is a little more work, but more importantly, we don't know what R prime is, right? They're not giving us that. And so, so since I don't know R prime, what I can do is I can plug in R in terms of H, because I know this relationship, right? I know that R radius over height is equal to 20 over 10, right? And that allows me to cross multiply here and solve for R. So 10R equals 20H. And then I can divide both sides by 10. And so R equals 2H. Okay. So because these triangles are proportional here, that means that there's a relationship between R and H. And what I can do is I can plug in 2H for R. Okay. And what that'll help us to do is restructure this formula. So I'm going to plug in 2H here and square it, right? It'll help us restructure this formula, so now it's all in terms of H. And so 2H quantity squared is 4H, okay? And then 4H squared, I should say. And so then 4 times 1/3 is going to be 4/3. Pi comes down, and then H squared times H is going to be H cubed, right? So that's our new formula. Now it's just in terms of H, so it saves us from having to do the product rule. But like I said, more importantly, we're just going to have an H prime instead of an R prime and an H prime, because we don't know what R prime is, right? Okay, so anyway, from here, now we can take the derivative with respect to time. And so what we end up getting is V prime equals 4/3. And let me do a little mental math here. So 3 times 4/3 is going to be 4, right? And then we bring down the pi, take away 1 from the exponent, so that just becomes H squared, and then we tag on H prime, right? And so now we're going to plug in the values that we have, right? So we know that H prime is -2, right? We know that H at this point is 8, right? So the water level is always changing, but at the point where we want to find V prime, the height is 8, right? That's what they tell us. And so, so now we just plug all that in, and we are going to find V prime. Oops, -2 there. All right, so go ahead and plug all that in. And don't plug pi into your calculator, just tag on the pi at the end. But you can do 4 times 8 squared times -2. And we get, all right, so volume, the rate of change of volume is going to be 512 pi. Don't forget the pi. And then what our unit's going to be if we're talking about inches in seconds. So for volume, it'll be inches cubed per second. All right, so there's our final answer. And don't forget your negative, right? Like this time's -2. So yeah, that was the whole point of this lesson, right? Is that we have decreasing rates, right? So if a cup is punctured and the water is leaking out, that means the volume of that water is decreasing, right? So don't forget that negative.